Okay, so what we're going to be doing today is making a 3D solid by stacking 2D shapes perpendicular to the 2D base. Keep in mind that the base and the stacking shapes, which we're going to call cross sections, could be the same, but they're probably not going to be the same shape. I will say though that this unit right here is really not that bad as long as you know two things, okay? One of them is you got to know how to find area of the base. That's what we did in 7.1. So those of you that feel a little behind on that, you're going to feel even more behind after today, but you got to get the 7.1 down, you know, before we do this. Okay, the other thing you got to know are these formulas to the right. So let's go over these and then I'll kind of explain why we need them. All right, so the first thing is, how could we write a formula for the area of a square with side s? This is an easy one. S squared. Okay, I know y'all know half base times height for triangle, but do you know the equilateral triangle with side s? Do you know that formula?
2s divided by 1.
It's square root of 3 over 4s squared. Now, even if you were in pre-AP or regular geometry, you actually did go over this, but that was a long time ago, so I don't expect everybody to remember that, but now you got to know it. This is going to be just a lot better to use than half base times height. I want you to notice how it's very similar to square. So it's kind of like if I can do a square problem, then an equilateral triangle problem, all I got to do is multiply by root 3 over 4. That's why we like that formula better. Okay, what about a rectangle of base S and height H? What would that area be? S times H. Notice there is no S squared here. So that one's different. And then a semicircle, this one's a little different. Okay, what I'm asking for is if you had a diameter S, what's the area of half the circle? So let's start off with what we know. Okay, 1/2 pi r squared, right? Y'all see why I'm doing the 1/2? Because it's a semi-half of a circle. Okay, what is r in relationship to s? It's half of it, right? So I'm going to go 1/2 s. And if you square the half and multiply that by another half, what would that give you? An 1/8. So we get pi over 8 s squared. All right, and the reason we like this formula is because it has s squared. So again, if we did a problem with squares, and then I said, oh, never mind, I want it to be semicircles, then all you would have to do is multiply by pi over 8 to make up for the difference. Okay, you need to memorize these formulas, not today or tomorrow, but by next week you should know these formulas. Okay, so we have these formulas, we're going to use them. All right, as far as what does S mean in the problem, I'm going to get to that part in just a minute. Remember also, like how we did with area, we have problems that are with respect to X and with respect to Y. With area, you got to choose, and I had told you that pretty much any problem can be done either way. When we're doing this cross-sectional volume stuff, you're going to be told if the cross-section should be perpendicular to the x-axis or to the y-axis. And that's going to tell you that you have to do the problem with respect to x or to y. So this has to do with are your shapes vertical, okay, which would be x-axis, or horizontal. So you don't get to choose in this section, which isn't bad, because sometimes choosing was the hard part for some people anyway. All right, now if you look at this problem right here, I'm going to show you a website that has some of this on there. All right, and what is the shape of the base? It's a circle base, and then the cross sections are all squares. So imagine if I just took one square. Wouldn't that area be s squared? That area would be s squared. And if I started stacking up lots and lots of squares, so many that I had a solid figure, if I added up all the s squareds, okay, by integration, okay, that would give me my volume. So let me show you what I mean. I'm going to show you a website, by the way. And if you go on my timeline to today and you click right here, the video link will be up after I finish this video. But if you click here, it leads you to this website. All right, so here's the 3D figure. It's just kind of going around, but more importantly, I want you to see how the shapes are being added here. And we could even rotate this around. So this is something that you can go on. It's a website. I think maybe it would even work on your phone. I'm not sure though. Now, what I'm going to do now is show you a different thing, all right, which you're not going to be able to ignore that for a moment. This is not something that you can get on this is like something I've downloaded and I have access to on my computer, but it works a little bit better because I can kind of move this around even more. So here is an example of that same shape. There's a circle base, and you can see here, if you look at it straight on, you can see those square cross sections or slices. All right, and that's what that looks like. So I want you to see, if I change these, if I keep a circle base but change to an equilateral triangle, look how the shape changes. And so this is an example. It kind of looks like a mohawk, I think. All right. By the way, how is this volume related to the first volume? Think back to those formulas. Times whatever this thing's volume is. If I times it by √3/4, I would get this thing's volume. Okay, look at the semicircles ones, and this is that dome that I was talking about earlier. Okay, so we can actually have a formula for volume of a sphere. We don't need it though, really. We can use calculus to figure that out. But how is this thing's volume related to the square's volume? Times pi/8. Now rectangles kind of odd man out. Because sometimes they tell you that the rectangle's height is like 2. Sometimes it's 2y. Sometimes it's twice the base. It just doesn't really follow those same things where you can just multiply by something, okay? Now here's where this thing gets really interesting. I can change the shape of the base. And so hopefully it makes sense that if you have a square base with square cross sections, you get basically a cube. But you could get all sorts of different prisms. Let me move over here to this mix. This is where we're really ultimately heading. Okay, so remember we did problems like this in 7.1. We graphed, this looks like a parabola here, or maybe a sine curve, or maybe something like that. And then this is a line, and we can find area by using integration. Now, if I wanted there to be, if I wanted to have cross sections, then I could actually find a volume. And this is kind of cool. It kind of shows us around. Now, you're not going to be able to do this for every problem we work. So the whole reason I'm showing this to you now is to give you an idea of what these look like, to kind of help you understand overall what we're doing. Eventually, we're going to have to be able to do this without visualizing the shape. All right, that's where we're ultimately going. So, okay, so here's how this actually works with the calculus. I know you guys are super excited and you can't wait to do some integrating. So, let's start a new problem, and let's do something we already know how to do, which is find area. Okay, so this says, using the equation x² + y² = 25, and it tells us to solve for x and find the area, not using circle formula. But this is a circle. What is the circle's radius? 5. Let's go ahead and graph this here. And this is going to help us figure out our bounds as well. Doesn't have to be pretty, just has to be good enough to help you with the rest of the problem. Okay. I know what this says to do, and we will do it, but anybody know the area of the circle? We're not going to do volume yet. We're just going to do what we already know how to do, which is area. How would you do that without calculus? What would the answer be? Yeah, 25 pi. Pi r squared, basically, okay? Now, this tells us to actually use the strategies learned in 7.1. So it says solve for x. Now, if you get x by itself, Which with respect to are we leaning towards? Yeah, because they will be in terms of y. So 25 minus y squared, and actually we would get x equals plus minus square root of 25 minus y squared, which does not simplify to 5 minus y. It does not simplify. We can go over another day why, but it doesn't. You can't square root each individual thing. Okay, so these are two equations representing the two halves of the semicircle. Now, because they're in x equals, it's talking about the right side of the semicircle and the left side of the semicircle. If this was y equals, it would be the top and the bottom part. And so, if you remember, what we did before is anywhere on here, since this is respect to y, we need to draw a horizontal rectangle. Again, right now, I'm just doing the old stuff. What is the area of this one rectangle? Okay, how do you figure out, like, from one end to the other? You subtract the right function minus the left function. Do y'all remember that from some point one? So the right function would be 25 minus y squared. The left function would be negative root 25 minus y squared. And then we multiplied that by dy because that was the thickness of that rectangle. So that represents the area of one of those really skinny rectangles. And then we integrated, and what would the bounds be on this problem? Yeah, we'd go bottom to top, negative 5 to 5. And what the integration does is it adds up all the skinny rectangles so that we get a shaded in area. All right, I already know the answer to this should be 25 pi. Let's go ahead and type it in the calculator and make sure that we understand how to type it in and that we end up getting 25 pi. And then we'll move on to the new stuff. So I'm just going to kind of go over this. You should have your calculator out doing the same thing. Be really careful with parentheses. Make sure you're keeping track of when you open parentheses and where they're supposed to be closed. The more you practice that, the easier it'll get. If you wait until the first quiz to practice this, you will get an error and you will not be able to figure it out in the time allowed. You've got to be able to put in the time in on this. And then you can just do a quick check. It'll spit it back out to you in Pretty Print, and you can say, yep, that's exactly what I wanted to type in. And remember, we knew we were going to get 25 pi just using pi r squared formula. And again, I'm starting with one we're comfortable with, and then we'll build up to ones that are brand new. Okay, so that was just a quick review of 7.1. Okay, so we're going to use this information in order to do the next part. Okay, so this is what I'm going to be finding in part 8. Let me remind you of what the picture looks like. It's a circle base with squares. I'm finding the volume of this shape right here, which is right up here, okay? So this is all part A. So if you want, you can try to draw this. It's very difficult, in my opinion, to draw. So this is one way we could draw it. Now I'm drawing the parallelogram for perspective. Okay, it'd be like this is S and that's S. So imagine this was like coming out of the screen at you. This would be perpendicular to the screen. So instead of finding the area of a skinny little rectangle, I'm finding the area of a square, which would be S squared. And then I'm going to integrate, which will take care of all of the cross sections. The integration part adds that up. Okay, just for perspective, it's like this is the square and there's S and there's S. That's the same thing that I'm drawing here. So to do the actual calculus, to do volume with squares, we need to integrate. Our bounds are going to be the exact same as our bounds were for area. Okay? The y values, since this is with respect to y. See how I skipped this, but I shouldn't have. Perpendicular to the y-axis means do this problem with respect to y. So that's good because I had already kind of set it up that way. All right, now, you already know the side. We found it. It's right here. Okay, that right there is the side. So this whole how do you find S? It's what we already practiced in 7.1. It's either going to be right minus left or top minus bottom, depending upon which with respect you do. Okay, so that's 25 minus y squared minus negative root 25 minus y squared. If I square that whole thing, that's how I'm going to get the volume of all these squares stacked on top of that circle. Okay, I know it's a lot. It's a lot going into one problem, and today's the first day we're doing it. So, you're going to be fine. You just got to hang in there. But I will tell you, if you're totally lost today, you probably weren't that great at 7.1 either. We got to get 7.1 down before we can really be good at this. Okay? All right, so before we type this in, let me just make sure everybody knows like why I've written all this down. What does the thing inside the parentheses stand for on this shape? The right side minus the left side is the S. Like this right here, that is the side of the square. It's right minus left. Why did I square that expression? Because the area of a square is S squared. Why did I integrate? Because I'm not just finding one square, I'm finding all the squares stacked together. All right, and that's what integration does. All right, now I'm not gonna type this whole thing in again. All right, we already have this typed in right now. So do you think we could edit this to make this inside part squared? And I'm going to actually start at the end. Go right before the comma y, put in an extra closed parenthesis, put in a caret 2. And since I put in a closed parenthesis squared, what do I got to do now? I need to put an open one. How far back should I go to put in the open one? Yeah, not quite all the way right after the integration part though. Not before the integration. Now, if you mess up, that's okay. You're going to figure out what you messed up on and then you're going to go from there, okay? This is what I was saying. If you do this for the first time on a quiz, you're going to get an error. We got to work through those mistakes. And I will tell you, 95% of the time, it's a parenthesis mistake. Look at all those parentheses. It's a lot. Okay? All right, so we got 2,000. I'm just going to write it down here. We got 2,000 over 3. That represents the volume of this shape right here. All right, now, the good thing is if we've done a square, we can actually do 2 more rather easily. Okay, because how was semicircle related to square? What was that formula? Pi over 8 s squared. Isn't pi over 8 just a number? This is not a trick question. Yeah. It is, right? And what do we do with integrals and numbers? Where can we move that number? Into the front. So you can just type that in, just like that.
Would it be 1,000
Mm-mm.
squared?
This 2,000 over 3 is representing this whole integral, including the squared and everything.
So that is sine squared.
That is the integral of sine squared. And I think that simplifies. Did I hit second? Oh yeah, here we go. There we go. 250 pi over 3. That's perfect. Okay, what about equilateral triangles? If we already know what the deal is with squared, how can I make that into the equilateral triangle volume? What do I need to multiply by? Look up at the top box if you need to. Root 3 over 4. So I'm not having to go through. I could go through and every time type this in anew. But why would I do that? If I already know that the integral of s squared is 2,000 over 3, I don't need to go through and type that in. All right, and you could probably simplify that, whoops, without the calculator. But why do it? We're having to do so much, like why do that part in your head? (500 root 3 over 3). Okay, I'm going to switch to a totally different color to do rectangle because it's different. It doesn't have an s squared in it. See how this says height of 2y? Let's just scratch out the y and do a 2. I want to start off with an easier problem this first time. Okay, so what would the area of that rectangle be with base s? S times h, right? And if we want to do volume, we need to integrate. Do we know the s? Yeah, we do. It's this whole thing. It's 25 minus y squared minus negative root 25 minus y squared. It's the right function minus the left function. I'll answer that in just a second. You can't, but I'll explain why. Okay, so this is our s. We don't want to square this, right? We want to multiply this by how much? What'd they say the height was? 2. Would it be okay to move that 2 to the front? Sure. It doesn't. It just depends upon what you want to do. Okay, you can move numbers to the front. So one thing to notice is that this whole thing right here is the exact same thing we did in part number 1. And what was that answer? 25 pi. So what should this be? 2 times that. That's going to be 50 pi. And you can type that in and get 50 pi. Okay, I'm just showing you ways that you don't have to type it in over and over and over again. Okay, so the big questions are, first of all, what can we just square or square root the answer as needed? And the answer is we can't, because the order that you do things matters. So if I kind of look back up here from number 1 to 2a, the only difference was I squared the body of the integral, and we can see that that did not give us a squared answer. So yeah, you can't do that. First,